All right. Insecurity of police department system. So I'm Vasilios Hioureas, malware analyst for Kaspersky, and I did this presentation, or this project together with a friend of mine, my partner TK, who's engineer at Exigent Systems. And so what basically this ends up being was our ability to monitor video feeds going throughout the city, blackout cameras, inject, replace video feeds. But most importantly was to force cameras, or not even force, more convince cameras to route all their packets to us. So essentially play the man in the middle. Okay, so my main contribution to this project was as a reverse engineer. In order to understand what was going on, there were some very specific devices. So we needed to get a hold of some firmware and some ARM firmware, and my main task there was reverse engineering that to try to figure out a protocol, whereas TK was the networking expert who set up everything and programmed the majority of the demos. So how this all started, the reason we got into this was, in general, me and TK constantly working on side projects, hacks, whatever technology we find interesting. And one day apparently he was out in the city climbing on some fountains, and he heard some voices from above telling him, hey, get off the fountain. So he looks around, he sees that there's some wireless, devices up there, and so he sends me an email, with about like a 20 megabyte attachment of some wireless dumps, and he's like, hey, how good are you at reversing protocols? So that's kind of how that started. And our main motivation, maybe besides just being bored or for fun, was kind of, in general, we sacrifice our privacy for protection in this scenario, so we wanted to see kind of how responsibly this is all being handled by them. So just a quick overview of what the network is that the police department had implemented throughout the city. It's basically your typical wireless technology, nothing very specific in that sense, but there's this routing protocol that is pushing packets from camera to camera to eventually make it to the police station where they're being monitored and recorded. So unlike traditional Wi-Fi, though, you can't just join the network and query for devices or intercept traffic from all devices. You'll only be able to see basically the traffic of whatever line you're inside of. So from one camera to another, if you were to intercept the traffic there, you would only have access to that specific feed from that camera. So because of that, you can't do your typical things for man in the middle that you would do for, under a normal network like ARP spoofing. You could do it, but you would only be able to act on a specific camera that you're near, so it wouldn't be very effective. In order to actually be able to operate on a wide range of the devices, you'd have to, essentially speak the same language. So, and this is why we had to analyze the firmware, to learn the protocol in order to be able to do this. And after we did this, it ends up being a lot more effective than your traditional techniques anyways. We end up being able to get a lot more information easier. So anyways, looking at the packets, the headers weren't enough to obviously understand the protocol. That's typically the case. You can't really understand a brand new protocol without any context. So we kind of had to first start on a physical level. We looked at the packets initially, actually, and just to see if it was anything common, and it ends up being a trade secret of this company, Firetide, who created the devices. So there was no luck there, so we had to basically take to the streets. And eventually, let's see. So anyways, so this is a picture. If you ever wanted to do something malicious, just crawl the city website. They gave us a lot of information. Here's just some locations of some key routing components that they use. So here's some pictures that we took of various things in the city, the cameras. You see directional antennas on there. So throughout the research, we found a ton of mistakes in general as far as how they set up and different things that were going on. But this picture here shows, in my opinion, what was like one huge and simple mistake that they made, which is leaving these things clearly labeled. So, like I said before, I mean, without knowing what device and what firmware to get a hold of, it would pretty much be close to impossible to understand any kind of protocol. But since this was here, we were able to see, exactly what devices they had. And so, it was just an eBay search, and we were able to get all the devices that we needed to set up our own little lab for testing. So, yeah. Let's see. So in general, they did, a sloppy job setting up. That was the first example. But, aside from physical mistakes, if you happen to be in line with one of these directional antennas, you would actually see, some Wi-Fi networks pop up. And, they had some really cryptic names like police department and stuff like that. So it was kind of a joke. But, I mean, I swear that they were asking for this to happen. Also going through the packets, we realized that everything was basically unencrypted. Even the primary data, the raw footage, whatever the cameras were sending, that was completely, unencrypted, uncompressed. So they basically did everything they could to make our lives easy in this thing. Because of that, our proof of concept, our demo, was as simple as parsing the headers and extracting video data based on the size that was specified. And then we actually end up having a live stream on our website of various videos, cameras in the city. Here's just like a little quick example of some, on the top there's your typical Wi-Fi headers, because these still use are wrapped in the normal Wi-Fi communication, and then underneath is a little more specific stuff with the meshes, the IDs, and different things like that, the length of the major data. So my reasoning here for the way they did just to set everything up was, I guess, in their minds, I imagine it's like, okay, we have some closed source undocumented protocol, and, we're using directional antennas, so it's not like somebody can just, connect with their laptop who's walking on the street. Because this was honestly the only thing, if you want to even call it security, that they had kind of, going for them. So, but, anybody who has any kind of motivation will obviously get past any of this. So, going through the code, I realized that there was an algorithm being implemented. And so here's some just code dealing with processing messages, receiving, registering IDs, receiving signal strengths, and different things like that. And eventually I realized that this was actually an implementation of A-star algorithm. And so I originally came from a game development background, so I've had a ton of experience developing pathfinding for various games. And in a situation like this, A-star would be used to get your guy from one place to the other. But when I first realized that they were using this, I got super excited because I knew exactly now what kind of control I could really have over this network. So just some basic theory, just for those who don't understand or don't know what A-star is. It's a very efficient pathfinding algorithm, and is based on nodes and weights. And each node has a weight, and so based from the weights and the vector, of where you are in regards to where you're going, will actually calculate the most efficient path. So if this demo is running live, for example, and I was to adjust one of these nodes that the blue line's going through, it would, you might see it take a separate route, like evade that square and go to something else, because it's not looking for the shortest path, it's looking for the quickest path, the most efficient path. So, and the nature of this algorithm itself makes it self-healing, so if, one of these nodes go down or the weight is extremely high, then it will route itself around there. And that's actually the key thing to what was so good about this and what we took advantage of in the system. So, here's just an example of what it might be in the city. Imagine it would start from the video feed would start from Fluid Mesh 2000, and the red house on top is like the police station. Okay, so clearly, like the first initial path, which would be the easiest, would probably be from Fluid Mesh on the bottom to Fluid Mesh on the right, and then to the police station. But for example, if a tree gets in the way, then the signal strength between those two might have maybe it's half the strength now. So it might make more sense the algorithm will have figured this out to take the route, which is the house right in front, to the next one, and eventually to the police station. So even though there's more hops, it still might make sense to take a longer route because of the reduced signal strength of this one. So, and another thing we found out in the firmware was that they use signal strength as their primary node weight. So for our proof of concept for our demo, what we did was, we registered ourselves as a node on this network in our lab, and we basically, what you do is you send the request and you lie to the rest of the cameras, or to the cameras surrounding you, telling that basically you have direct line of sight to the end node, to wherever the goal is. And so what happens is that, if I was to tell them that I have direct line of sight to the police station, what's going to happen is everybody's going to be pushing all their packets to me because they think that I'm the best way to get there. So, and they do no checks to verify has it arrived or has it gone anywhere. They just simply, okay, I've sent them what my connections are and what my hops are to the home, so they just trust that. And so we end up receiving basically with, all of the data that, that is in the general region of, cameras, let's say, that were set up. And so at that point, it was simply, if we did nothing, if we just discarded anything that we received, then the police department would essentially see black screens. So that's how we were able to black out cameras. So, anyways, taking it a step further, we wrote a program to parse the headers, and what happened, taking it forward from the blacking out cameras, you iterate through our pre-recorded video feed, and any packet that we would receive that was dealing with the video data, we'd find its size and just replace what was currently being sent by a camera, and we would replace it with our pre-recorded video feed. So then we would be able to essentially be able to fake, transmissions that were going across. So potentially dangerous scenario. One thing that I didn't mention so far, and it's something that we didn't specifically analyze, but some of the police stations, cities have this thing, which is inside of the police cars, the exact same mesh node that is used for the cameras, but they actually also have a GPS attached to them. And we didn't do any analysis of this yet. It was something maybe we talked about doing in the future, but judging from how completely insecure everything else is, I imagine it would be as simple as, querying for these and getting GPS coordinates. But so you can imagine now that you'd be able to easily make, a real-time police map of, every car in the city. And if you combine that with what we've done so far, which is, this whole video manipulation, an easy scenario would be, somebody stage a fake, event going on in the city, pre-recorded, and, watch the police respond to it, and then you'd have a window of opportunity on the other side of town to be able to do whatever you want. So, but yeah, we didn't actually do this, but this is just kind of theoretical. So, let's see here. So yeah, something as simple basically as being able to monitor videos, it could lead to, as you could see, something devastating in attack if there was any criminal motivation behind it. Kind of to conclude, my main point is not to say anything bad about Firetide, just in case if it sounded like it. It's actually, it's a good product. It's not the hardware itself or the software itself that's the issue, because it's just very complicated, and it's not Firetide's fault at all. Going through the firmware, actually, I ended up seeing a lot of modules there who were specifically for encryption, for protection, and it's just that these weren't being implemented. So that's the issue with just pulling something off-the-shelf hardware and throwing it without any real knowledge. It's just that it gets misused, and and that's kind of the whole issue here. the main point is kind of, back to what I initially said when I started, was we do trade off our privacy for this, security, and some can argue that maybe that's a fair trade, but it's unfair when it's, unresponsibly handled, like in this case, for example. As far as the demo goes, so I had mentioned the demo. I'm not able to show the demo, and the reason being is that recently, police department actually turned on web. So, congratulations to the police department for upgrading security to 1990s era technology. But the problem, though, with that is that, even though it's obviously simple to just crack it, in order to show the demo, if we did show the demo at that point, we'd be crossing from taking public open data to now having broken into their network and kind of stealing, at that point, private data. So, don't want to end up walking out of here in handcuffs or something, so we can't show anything. Actually, that's it.